Hello my friends, alright, are you ready to train the k-means model on the dataset now that we have the optimal number of clusters? Let's do it. I hope you did it before me, right? You know how to do it, but you will see that we will do something extra in this tutorial that I don't expect you to find at this stage, but you will see that it's going to be a trick to get to our final result faster. Alright, so let's do this. Let's create a new code cell, and you know how to do this. The first step here is to create an instance of our k-means class, which we're going to call once again k-means, and that is exactly going to be the k-means model itself. But this time we're going to create it with the optimal number 5 of clusters that we found in the previous step. And so here we go. Let's call first the k-means class with capital K and capital M, and let's enter already our optimal number of clusters, 5. Alright, that's the optimal number of clusters for our dataset we found in the previous step. The next argument, the initialization method, which we're still going to choose to be k-means ++, right? That's the most effective one. So here we go, let's copy this if you want to be lazy like me, and then paste it. And finally, if you want to have the same results as me, well, we can add this random state parameter and set the same value of, for example, 42 for all of us to end up with the same result. Alright, so this creates the k-means model, but it is not trained yet, and so our next step is exactly to train it. And to do so, well, as we did before, we can call our k-means object, from which we can call the fit method, which takes as input our array of independent variables, from which it's going to find the clusters. And that array of independent variables, well, that's what we got in the first step when importing the dataset, and we called it x. Alright, so far, that's exactly the same as what we did in the loop. But now we're going to add this little trick to get to our final results, meaning the patterns, the clusters, faster. Alright, and this little trick is not to use the fit method, but the fit_predict method. This is another method, as you can see, by the k-means class, which will not only train your k-means algorithm with that optimal number of clusters 5 that you specified when creating your instance, but that also will return to you, thanks to this predict part, well, the 5 clusters themselves. And how will it return them? Well, it will return them in the form of a vector that is going to tell you for each of the observations of your dataset, therefore each of the observations in X, the number or the index of the cluster that observation belongs to. And since our optimal number of clusters is 5, well, this fit_predict method is going to return for each of the observations in X a number between 0 to 4, because indexes in Python start from 0. Alright? Don't worry if it's not crystal clear yet. What we're gonna do now is visualize this vector of clusters, and I will re-explain this by visualizing it. Alright? So, speaking of our vector of clusters, well, let's create a variable that will be exactly this vector of clusters and therefore the output of this fit_predict method. Alright? So we're gonna call it y_pred again, because this is not a vector of predictions like before, but a vector of identified clusters. Okay? So ypred, and so now, well, we have everything. We're ready to run this cell to not only train our k-means algorithm, but also already return all the clusters to which each of our observations belongs to. Alright, so let's run this cell. Here we go. Successfully run. And now, as I promised, let's create a new code cell to have a look at ypred, our vector of clusters. There we go, ypred. And so as you can see, as we said, this vector returns values from 0 to 4, where each of those values here is the cluster index to which the observation belongs to. So now, what I'm going to do is I'm going to add another code cell here just to plot x again, just to visualize x again. And let me re-explain what happened. So this is a first customer. The first row of X here is the first customer having an annual income of $76,000 and the spending score of 40. And well, the k-means algorithm identified that this customer belongs to the cluster of index 2. Then the second customer who has an annual income again of $76,000 and this time a higher spending score of 87 was identified to belong to cluster number 3. Okay? And then now I guess it's more clear. The third customer belongs to cluster number 2, then the fourth customer belongs to cluster of index 3, and etc. until the last customer. Let's actually do the last 3 customers. This customer who has an annual income of $126,000 and a spending score of 74 was identified by our K-means model to belong to cluster number 4, or cluster of index 4. And then this customer who has an annual income of $137,000 and a spending score of 18 was identified to belong to cluster number 1, or cluster of index 1. And finally, I'll stop here, I promise, this customer of annual income of $137,000 and a spending score of 83 was identified to belong to cluster number 4. Alright, so now I hope you get it, I hope it's more clear. And so actually, what I've just explained with a few customers here, well, we're going to visualize for all the customers the clusters of those customers. Alright, so that's exactly what we're going to do in the next and final step of this implementation. So again, there's going to be quite a bit of code here, so please grab a good coffee or make yourself a nice tea, and I'll see you in this next tutorial to tackle our final step. And until then, enjoy machine learning!